Nice to have you here. The speed of light is the fastest. The speed of light in vacuum is the fastest speed in the physical universe. Nothing can go faster than the speed of light in vacuum. However, when light goes through media that are not part of vacuum or other media, they are slowed down by an amount that is characteristic of the material, such that the speed of light in vacuum C divided by the speed of light in any material or any other medium V gives us the refractive index, a characteristic of the medium with lots of cool applications, which is our topic in this fifth episode of our research recap for the future. So refractive index, RI, from cosmetics to aeronautics. Guess what? Look, even our eyes, our eyeballs, the lenses in our eyes, refractive index. Nature selects it very well and gets it to focus in the retina, enabling vision. Corrective lenses, refractive index again. Fiber optics communication, total internal reflection, refractive index again. Microscopy and imaging, getting the images, getting them sharply focused, getting them enlarged is a matter of optical properties arising from refractive index. RI in food and beverage quality testing, yes, the sugar content of fruits can be determined by refractometry, measuring their refractive index. How cool. Jewels, oil and gas exploration down into the earth crust, the amount of bending or changing of the speed of light is key to that exploration. Cosmetics and skincare. Let's go slightly deeper there. You know the foundation, you know the concealer, the chemists, the cosmetic chemists, they know how to select the refractive index correctly so that the reflective properties that we get in the end would be pleasant to the eye, a lot of index matching and so forth to make cosmetics work. Okay, aeronautics, optical equipment, the instruments that pilots use as they navigate the atmosphere with the aircraft depend on refractive index of the air in order to use them correctly and know where things are. How about space exploration? Let's just take a look now. LEDs and lasers, photodetectors, optical filters and coatings, solar cells, all are cool instruments needed for space exploration based on refractive index. Now, not surprisingly, one of the Nobel Prizes given in physics this time, 2009 Nobel Prize in Physics was awarded to Sir Charles Kao for his groundbreaking achievements concerning the transmission of light in fibers for optical communication. He basically was among those who launched the information age thanks to optical fibers. You see them, they are the ones connected to those poles that are part of our cell phone transmission and picking up. Now, refractive index. How did I work with refractive index in my lab? Well, we used a digital holographic microscope, DHM, to measure refractive indices of individual biological cells. More precisely, the change in phase, the optical path difference that depends on the refractive index. That's what we measured for each biological cell. And that led to discoveries, increased understanding in the area of cell physiology, precisely in terms of cell differentiation. So we published this paper titled Quantifying Cellular Differentiation by Physical Phenotype Using Digital Holographic Microscopy. That's long, but that's what we did, and you can get the details down below. Another application, this time instead of physiological, pathophysiological. So we were able to pick up changes in refractive index following bacterial infection of macrophages. So that's a way of picking up pathophysiology through RI. Lots of applications. So what does the future hold for refractive index? I can see clearly a combination of RI and AI, and it is already happening in augmented reality, in mixed reality, and will continue to be important for the characterization of what is described as metamaterials. So dynamic characterization of new materials that are important for new technology. So refractive index will continue to be very, very important way of characterizing materials for the future. So these are some of the fun people that I worked with in the measurements and in the characterizations and discoveries that I spoke about. I'll talk about some of these discoveries again, and I look forward to meeting you in future research recap. Stay tuned. Thank you.